Welcome to a masterclass in deep woods resilience. Let's watch the incredible journey of Karakum outdoors as the builder constructs a phenomenal wooden survival shelter, demonstrating techniques that fuse raw power with calculated efficiency. This endeavor is a testament to the quiet strength of the human spirit and the timeless art of bushcraft. Let's embark on this long, peaceful, and beautiful journey of the craft and the shelter building. Expanding a natural hollow requires extreme caution. You must excavate the rot to prevent fungal spread to your gear, but meticulously avoid compromising the tree's structural sapwood, which bears the load. Clearing punkwood eliminates moisture traps and insect habitats. A clean, dry interior cavity is absolutely critical for preventing ambient moisture from sapping your core temperature in damp environments. Securing the bark early establishes a dry microclimate to work under. Widening the entrance is tactical. It ensures rapid egress in an emergency while minimizing the aperture for cold drafts. Exposing internal insect galleries highlights the danger of depth falls. The builder must constantly assess if the core wood remains dense enough to safely support the massive weight of the upcoming roof. Creating a precise doorway isn't about aesthetics, it's about thermal dynamics. A tight squared fit is necessary to eventually construct a door that completely locks out freezing winds and predators. Managing the debris field immediately is a hallmark of a professional. Clutter causes tripped ankles and tools to be lost in the dirt. Severe hazards when medical evacuation is not an option. A subterranean profile capitalizes on geothermal insulation. By trenching down, the builder entirely escapes freezing surface winds and harnesses the Earth's stable ambient temperature to drastically increase survivability. Root systems are formidable obstacles. Severing them cleanly with an axe, rather than hacking blindly, preserves the tool's vital cutting edge and prevents dangerous, glancing deflections in the tight trench. Trench depth must be highly calculated. You need enough clearance to sit upright to manage your core temperature and gear, but digging too deep risks hitting the rising water table. Vertical, smooth trench walls prevent sloughing and catastrophic collapse. This structural integrity is a non-negotiable requirement before committing to adding a heavy timber and earth roof overhead. Encountering thick taproots violently drains physical fortitude. The expert technique is clearing the soil completely around it first, ensuring maximum axe penetration and completely preventing dulling strikes into the dirt. Unearthing grubs presents a prime opportunity for sustenance in true survival. The continued leveling of the floor is crucial for creating an ergonomic sleeping platform to preserve heat and prevent fatigue. Leaving loose aerated soil on the floor absorbs moisture like a sponge. Scraping down to the hardpan is essential to prevent damp earth from seeping into and compromising your sleeping gear. Notice the deliberate squaring of the trench corners. This geometric precision ensures that structural roof logs will sit perfectly flush later, eliminating gaps where freezing air could penetrate the shelter. Discovering an icy patch dictates the mandatory construction of a raised bed later. Sleeping directly on frozen ground will violently and lethally strip your core body heat via conductive cooling. The final grading is executed with extreme care. A perfectly level footprint ensures that the massive structural loads of the wet earth roof will be distributed evenly into the ground. Creating an asymmetrical point on the structural stake prevents the wood from splitting when pounded into frozen earth. This is textbook bushcraft engineering for creating reliable structural deadmen. The lateral alcove being excavated acts as a cold sink. Dense, freezing air will naturally flow down into this lower depression, keeping the primary elevated sleeping platform significantly warmer. Sod provides exceptional insulation. Harvesting it intact with the root matrix preserves its structural integrity, creating a living roof that naturally sheds water and traps radiant heat inside. Sourcing highly plastic clay is vital. This acts as nature's concrete, an essential resource for fireproofing internal structures and creating a completely airtight seal against winter gales. Kneading dead grass into the clay matrix introduces essential tensile strength, identical to rebar in concrete. Without this fibrous binder, the dried clay would inevitably crack, crumble, and fail. Crafting the draft hole requires an understanding of fluid dynamics. If the diameter is too large, it vents precious heat. Too small and lethal carbon monoxide accumulates rapidly in the trench. Testing the draw of the chimney early is incredibly smart. The smooth extraction of smoke confirms the thermal draft is functioning correctly, making the enclosed space safe for prolonged habitation. Selecting suspended deadwood is crucial. It is pre-seasoned and dry. Gathering timber directly from the forest floor risks introducing severe rot and heavy moisture into the shelter's roof. Processing the timber to uniform lengths before transport heavily optimizes physical investment. Every motion in a cold weather survival scenario must be calculated to conserve vital, irreplaceable internal resources. Carrying heavy loads over uneven terrain is when most catastrophic wilderness injuries occur. The deliberate paced movement back to camp mitigates the severe risk of a twisted ankle or broken bone. Laying the rafters perpendicular to the trench requires a precise, calculated overlap. These primary timbers must comfortably bear hundreds of pounds of wet earth and winter snow load without failing. The tight, methodical clustering of the roof logs minimizes the amount of debris chinking needed. The roaring fire below now safely begins the crucial process of baking and curing the clay mortar. With the primary rafters positioned, reinforcing the roof load-bearing structure becomes the core focus. Selecting straight, uniform secondary logs prevents structural twisting. This tightly interlocked timber foundation ensures uniform weight distribution before massive layers of insulating earth are integrated onto the roof frame. Felling deadwood with precision mechanical strikes optimizes kinetic output. Striking at an exact 45-degree angle ensures maximum penetration per blow. Standing dead timber is ideal because its lack of internal moisture guarantees immediate thermal utility and a high strength-to-it ratio for ongoing construction demands. Mitigating canine exposure to external hazards is a critical camp management task. Assigning a secure, temporary shelter within a natural hollow minimizes distractions. This allows the builder to execute high-risk physical maneuvers safely, knowing the animal is protected from flying wood shards and predatory oversight. Harvesting dense sheets of seasoned bark introduces an irreplaceable waterproofing element. These large natural shingles act as primary protective membranes. Proper orientation of these sheets leverages the wood's natural grain to shed heavy precipitation outward, preserving the underlying earth and timber layers from saturation. Executing controlled low-impact splits across the log faces preserves crucial tool geometry. Maintaining a consistent strike path prevents unexpected deflections that could dull the bit against ground obstacles. Efficient material processing at this stage is vital during protracted winter builds. Manually deploying heavy structural cladding requires optimal ergonomic lifting techniques. These high-mass bark segments serve as an external shell, neutralizing high-velocity wind infiltration. By eliminating the wind chill factor, the builder protects the shelter's developing thermal envelope from convective heat loss. Applying a dense layer of hydraulic mud over the timber framework initiates the traditional wattle and daub seal. This step is imperative for complete hermetic isolation. The clay-rich mud eliminates remaining microgaps, trapping rising heat and forming an impenetrable barrier against overhead moisture penetration. Erecting vertical bark partitions demands meticulous spatial calibration. Minimizing tolerances around the perimeter is essential for controlling atmospheric exchange. A tight fit shields the core shelter from rapid cooling and establishes a distinct boundary against nocturnal predators. Extracting a partially buried slab of dead tree bark demands aggressive leverage and controlled force application. After dislodging the bark from the frozen earth, the builder clears away embedded debris and refines the material with deliberate axe strokes into a rounded protective canopy. Positioning this natural shield above the shelter entrance establishes a critical overhead barrier, preventing direct rain penetration until a final mud seal can later complete the waterproofing process. Carefully packing wet mud into the wall joints is called chinking. This process blocks tiny paths where air can pass through. In harsh wilderness conditions, stopping cold drafts is more important for preventing hypothermia than simply adding thicker insulation. Checking the inside of the shelter while the fire is burning reveals important structural leaks. Finding spots where light or smoke escapes allows quick repairs. Making sure the shelter is fully sealed improves heat efficiency, turning the trench into a highly effective heat-retaining shelter. Collecting large amounts of dry forest debris improves the gathering of natural insulation. Dead leaves trap pockets of still air, which greatly reduces heat loss to the ground. Using a carrying sack also reduces travel time and saves valuable energy. Spreading a thick layer of packed leaves creates the base of the thermal bedding. Direct contact with frozen ground quickly causes body heat loss. This deep layer forms a protective barrier, separating both the builder and the dog from the cold earth below. Choosing a large, curved slab of bark begins the construction of the shelter's main door. Removing inner layers with careful axe strikes reduces extra weight while keeping the bark strong. Hollowing the inside also makes it easier to carry and position the finished door. Custom fitting the entrance door requires careful shaping to remove gaps. The door is one of the shelter's biggest weak points for heat loss. Matching the natural curve of the tree bark creates a tight seal, blocking freezing drafts from entering the shelter. Drilling anchor points into the wood requires steady force and control. Hand boring through dense wood grain needs constant pressure monitoring to avoid splitting the material. This step creates strong mounting points for camp tools without using modern metal fasteners. Building tension-based wooden parts demonstrates classic wilderness engineering. Locking the wooden pieces together without metal hardware uses natural friction and weight balance. Careful construction ensures the finished structure can handle long-term use in the wild. Using a counterweighted pot crane allows adjustable heat control while cooking. Changing the height above the fire gives better control over cooking speed. This setup helps prevent spills and improves the use of the fire's heat. Sitting inside the finished shelter confirms the effectiveness of the design. Heat reflecting from the earth and mud-covered walls balances the falling outside temperature. Constantly checking airflow also keeps clean breathing areas while maintaining strong heat retention. Preparing food starts with boiling carbohydrates. Following proper food safety practices in remote areas helps prevent serious illness. Boiling sterilizes the water while turning dense food into usable energy for the body. Adding root vegetables provides important nutrients and natural sugars. An experienced survivalist manages food intake carefully to support heavy physical work. Cutting the ingredients evenly allows faster cooking while reducing fuel use. A steady rolling boil shows effective heat transfer from the fire to the cooking pot. Watching the liquid level prevents burning and helps preserve nutrients. This hot meal works like an internal heat source, raising body temperature before rest. To experience more of this creator's incredible journey and enjoy the original content firsthand, please visit the official links available in the description and support Karakum Outdoors on YouTube. There you can explore his full collection of amazing outdoor and survival videos directly from the original creator. This remarkable wilderness project reaches its final stage. It is also the perfect moment to recognize the extraordinary craftsmanship. We extend full credit and appreciation to Karakum Outdoors for the outstanding survival expertise and hard work. The level of detail, resilience, and outdoor knowledge displayed in this project continues to inspire wilderness enthusiasts and survival audiences around the world. We are truly inspired by the mastery and dedication shown throughout this project. Thank you sincerely for watching and appreciating the artistry behind this incredible build. And feel free to share your thoughts and feedback in the comments below.